Alright, I have a final tutorial video for you here. This is a hard example of a balancing reaction, but what makes this hard isn't how long the individual problem is, it's the fact that the formulas for the individual chemicals are so long that I'm going to have to put this on two separate pages. So these are the reactants, and these are the products. So this is what goes in, which is aluminum sulfate and calcium hydroxide. And what comes out is aluminum hydroxide and calcium sulfate. This is what we call a double replacement reaction, where the aluminum and the calcium switch places. And then the, I guess the way I have this drawn, technically the sulfate and the hydroxide, SO4, and the OH trade partners. It's called double replacement reaction. But when we go back to our rules here about what the individual formulas mean, this means I've got 2 aluminum, Al, SO4, 1, 3 times. So this kind of gets stuck right there. And then CaOHOH. So just one of these is going to be Al, SOOOO, and then that goes on and on and on. So one of these is humongous. And again, I tried to prepare you guys for this when I gave you the BC 5 worksheet while we were still in class. This is actually an example on that worksheet if you found practice with interpreting chemical formulas. On the product side, this is ALOHOHOH. And then CaSOOO. All right. So that was the hard part right there, was getting this one humongous formula out for one chemical. This is one thing. So if I needed so much as to get an extra S, I'm going to have to make this whole thing over again. So let's hope I don't have to do that. If I look, I have 2 aluminums on this side and only 1 there. So I need to duplicate this one. But again, the whole thing comes with it. So my aluminums are good. Next thing I notice is I have 1, 2, 3 sulfur. 1, 2, 3 sulfur on the reactant side, and only 1 on the product side. So I don't need to get 2 more of those. And again, they come with things we might or might not want as far as our balancing work goes. So at this point right now, we've got 1, 2, 3. Now, can you guys see any of the issues? Our S's are okay. I haven't even counted my O's yet. Let's look at our calciums. 1 calcium there, 3 here. So I'm going to need 3 more calciums on this side. Sorry, 2 more. For a total of 3. And again, those all come with elements I might or might not want. So let's take stock. 2 aluminum, 2 aluminum. 3 sulfur, 3 sulfur. 3 calcium, 3 calcium. Let's pray to God our O's and our H's match up. I've got 4, 8, 12, 13, 14, 15, 16, 17, 18 total oxygen right now. And 1, 2, 3, 4, 5, 6 hydrogen right now. Let's hope that matches up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 oxygen, and 1, 2, 3, 4, 5, 6 hydrogen. And like I mentioned already, 3 sulfur, 3 calcium, 2 aluminum. That's the same on this side too. 18 oxygen, 6 hydrogen, 2 aluminum, 3 sulfur, 3 calcium. So it just has this one humongous formula where if we screw that up, where we're going to go down a lot of dead ends because our equation won't work. But at the end of the day, our answer is just 1, 3, 2, 3. So all that work to get 4 little numbers. But those numbers are really, really important when we get to stoichiometry. So I hope this is all helpful. I would say another hard example. I don't think there's anything like this in our practice examples, but I don't really remember. I made 29 examples at the same time, so I can't really say for sure what I did and didn't do, but there it is. That's your hard example, your last one. So there should be 4 tutorial videos up at this point. If you've gotten through all 4 of those, that's more than what I would have done in class to help you out. So come to my office hours this week and see me there and ask me some questions. Maybe I'll be able to work one out on the screen there. But I love you guys. I miss you all. Hope you're doing well.